you're just like.
So you started spamming the Discord chat.
No, but
Yeah, but that's what it's designed to
nobody
do.
gets notifications and nobody like actually reads it, and so it's just like a short.
It's kind of like the same as the WhatsApp, no, when they actually read it.
Yeah,
No,
but
the
the
WhatsApp
WhatsApp
people get
sometimes we say
notifications.
important stuff.
Yeah. I had a meeting with lecturers in the math department, and they complained that I didn't share with them a certain information. And I told them we sent it in the mail, and they told we're not reading the mail. No, because the mail they read, but not the attachment. Yeah. Yeah. Okay. And calculus. Sammy is having a self-conversation. Don't interrupt him. Yes. Yeah, exactly. I zoned out for a second, started making Chewbacca noises. Sammy, I think you're having no, a ChatGPT addiction. I can stop whenever I want. ChatGPT, how can I stop using ChatGPT?
Right now.
What?
It's a fast rise, then a crash right in the middle of your answer.
Okay.
Look, if you crash all the time, it doesn't matter. So just
just one time he did just lie on the floor, right? And you cannot crash lying on the floor. Okay, so a quick recap. Yes. Yes, it's not a joke.
Yes.
It's truth. Okay. There's no way to להידרדר to מה זה להידרדר?
To worsen?
Yeah. Things cannot be worse once you hit rock bottom. Okay. Okay.
What's perspective? It's not a downward spiral, just a turn.
Yeah. Yes. Okay. So in that domestic note, let's get things worse. We learned about the definition of derivatives last time. This is the visualization of it. I wanted to derive this function. I will do the calculation of this today. I want to derive this function so at 0. So I take another point on the graph. I take the chord, not this chord, the chord, which is the line between the two points, and then I do the limit of the gray point towards the red point, and I'm looking at the slope, the function of the slope of these chords, and I'm asking whether does this have a limit. In this case, it did not, because the chord was waving between 1 and -1 slope. And at this example, it did work. And did I give you at this square root? It also worked, and much nicer. And these were the general examples we saw. The visual, it was never, we didn't yet do one actual example. We will do such example now. Note before I do the example. note before I do the example. The derivative, I'm reminding you, is the limit as x tends to x0 of f of x minus f of x0 over x minus x0. And it's an easy exercise to show that it's the very same thing as the limit as age approaches 0 of f of x0 plus age minus f of x0. You see the thing? Instead of calling the 2 points x and x0, x0 remains the same, and the second point is x0 plus some distance. And what should I divide with? Age itself. That's the distance between the 2 points, and age goes to 0. So you can use either version, they are completely equivalent. Sometimes one is a bit easier algebraically than the other. So I use sometimes this one, sometimes that one, but like I said, they're completely equivalent. So now, yes. A what?
Homework. Yeah.
HW is homework. I used to use HM, but they said it's not true. So, so why are you asking me?
Well, I thought it was homework, but it didn't make sense in the context. I thought it was something. Love you too.
No, I don't want you to.
Please don't.
Yes. Yesterday, one last thing of an anecdote. Yesterday, someone said to another colleague, 2 colleagues of me talked, and one said, "Oh, we need to do this and this." And she said, "Yes, Gil mentioned it." And he said, "Yes, I'm Gil." Okay. So it was kind of like the same. Let's derive fx equals the square root of x. So what's the derivative? Yeah, great. I was looking forward for that joke. We'll derive, it wasn't a joke. We will derive it ourselves. It's the limit as age goes to 0 of the square root at x plus age minus the square root of x over the distance between the 2 points, which is age. Agreed? By the way, in this case, I told you one may be preferable to the other. In this case, they are both the same. The reason I chose this one is because I don't have to write x0 because the other letter is age. When I use this one, I always must use x0 and x. Silly reason, but a reason nonetheless. So where does the numerator tends to? Numerator is up. 0, right? Because this goes to square root of x. X is a constant, it's a parameter. And this is square root of x, so the numerator tends to 0. Where does the numerator go to? Also 0. What can we do? Give me the stupid answer. No, that's the true answer. No, L'Hopital rule. And why is that the stupid answer? Because in order to do L'Hopital, we must be able to derive the function, and that's what we're doing now, okay? It will work, but it's stupid, okay? Because we need to know the derivative. But yeah, multiply and divide by the complement, by the conjugate is the thing to do here. That's the limit as age goes to 0 of the same thing times the addition of the square roots over the addition of the square roots. Okay, agreed? What? And the limit as h goes, that equals the limit as h goes to 0 of. So a minus b times a plus b is a squared minus b squared. That cancel the square root. We have x plus h minus x in the numerator, which is up, over h times the addition. The real question is, why is it called denominator and numerator? It should be called denominator and numerator. That makes sense. Okay.
So
Denominator, numerator,
numerator.
yeah, it makes sense. Nominator, yeah, that makes sense. Why? Yeah.
Nominator for what?
You're a nominator to be up. No, you're the one doing the nominating. Okay, I'm sorry. What's next? What's next? We cancel out the x on the top, and then we cancel the h both on top and bottom. And we are left with 1 over this. Agreed? What does this tends to? No. 1 over 2 times the square root of x. Because h goes to 0, but x is x. Okay? But I will say, note that if x is 0, the limit, one-sided limit, because the other side is not defined, is infinity. It is important because a square root is underivable, is not differentiable at 0. That's the reason that the cubed root is not differentiable at 0. It's a very similar calculation. No, square root is defined. The square root, no, not the derivative. The function square root of x is continuous at 0, yet not differentiable. So with square root, it's a bit confusing because it's only one-sided. But if you do it on the cubed root, it's continuous throughout, yet at 0, it's not differentiable. That's what I showed you last time, because the limit is infinity.
For all even and even powers? Or square roots, I mean?
Yes, and I thought you asked something else, if it's the root of all evil. But the answer is also yes. Why? Why? What is the absolute value of x? It's actually the square root of x squared. Agreed? So the square root is the root of all evil, or at least all continuous but non-differentiable functions. It's not exact. We could find other examples as well, but in a sense, it's the sense that's true, and it's also explains why do we say it's non-differentiable. Because we talked about it, the cubed root, and we said, but geometrically it looks so differentiable, the red line. Why shouldn't it be differentiable? But then you see stuff like that suddenly, when you plug in something, it becomes not differentiable. Yes.
I get to go on my tangent today.
Yeah.
So this works because the even roots of negative numbers don't exist, right?
Yeah, but that's not the point. That's why I'm saying the cubed root also, the limit will be 0 here if you calculate it. The slope is infinite,
But yeah, but it's not.
not just for the even, just for the non-even as well.
Okay. So in the imaginary number fields, even roots are also not differentiable.
In the complex numbers, roots are not defined even. What is the cubed root of 1? There are 3 options, right? It's even worse because in the I'll give you a short answer for that. Do you agree that 1 is the square root of 1? I'm not sure if I've shown you this.
Yeah.
Do you agree it's the square root of -1 times -1? I did show you this in calculus, I think, with the limits of, with the rules of powers of exponents, but now I'm going on another direction. Do you agree it's the square root of -1 times the square root of -1? Let's say square for sake of simplicity. Do you agree about that? What is the square root of -1? I squared, which is show me the lie.
No, because the square root isn't equal to the square root of -1 squared.
Why?
I mean, you mean because of the order? You can reorder it if you want.
It's 2 times the square root of -1. I wrote it squared for simplicity. It wasn't the point. I could write square. I'll do it.
Oh,
Square root of -1 times square root of -1. Fine.
because 1 doesn't equal square root of 1.
It's definitely, most definitely does.
I think the other way around.
No, the square root of 1 is 4. Yeah, no.
Yeah.
No, it is 1.
I don't even think like a square root of 1 equals to square root of -1.
Because the reason
That is the same
reason-
level of
the
stupidity,
reason-
because -1 times -1 is most
Yeah.
definitely 1.
The reason is because square root of negative numbers isn't defined for real numbers.
And I'm doing it in the complex number field. Oh, then that it's true. Then 1 equals -1.
I'm trying to do the most stupid.
Yeah. Yes.
Is it splitting it up?
Yeah, so first of all, yeah, there are 2 possible answers. This one and this one. Why?
Because 1 is
Because what I told Thomas, it's not clear that roots are defined in the complex numbers because there are 2 solutions. I is one solution to be the square root of -1, but -i as well. How do you choose? So in roots of real numbers, we always take the positive solution, given the chance, okay? But in complex number, there is no concept of positive or negative at all. So that's one problem. So one of the ideas is to define the root as to be the one with the least angle, the first one on the circle. But then the rules of exponentiation do not work. It doesn't split. So either one of these 2 can be considered to be the problem. So roots, it was non-relevant one L? Yeah, non-relevant exact. These are examples I like to show students, but it's not like part of the syllabus. So yeah. Yes.
I'll go up to our original example. You use x instead of x0. Is there a reason to change it?
I prefer to use x as I can. When you write the derivative of square root of x, you write square root of x, not x0.
Okay, fine.
So I
then in the
prefer it.
definition-
Here, I couldn't do that because I have both x and x0. I need to separate them. Because here I have x0 and h, I can just write x instead of x0. That's not math, it's just...
No, but it's difference in
There is no
no, in the left, X is
goes to x0, and here age goes to 0, yes.
the variable X0 is a specific.
Yes, and here age is the variable and x is the specific parameter or value. Here. Okay, age moves. I am asking what would be the the derivative of the square root of x at the point x.
Because we're using X as a generalization, it works for
Yeah, for every x.
points apart from when we get our derivative, because X being 0 would be.
Yeah, and if x being 0, then here we have a problem. This last step is false because this tends to 0 and 1 over 0 is infinity because it's positive. Okay. Something an important example. We said, we defined, not just said, the tangent to be the line with slope f tag and f prime, and that passes through the given point. Okay, let's calculate. Let's calculate I'm thinking about it for a second. Want something interesting, but true. Okay, let's calculate the tangent line for f of x equals the cube root of x at x equals 8. You will see why am I doing it. First, we will create a general formula. The slope at x equals a is f prime of a. The point on the graph at x equals a is a comma, what is the y value? What? F of a, exactly. The formula for a line given a slope and a point is y minus y0 equals m times x minus x0. Is that familiar? Yes? Okay. And now I wish to plug in the tangent. What do I know about the tangent? I know the slope and I know the y value. So the tangent is y minus f of a equals f tag of a times x minus a. Agreed? Which means y equals f prime of a, f of a plus f prime of a, x minus a. Okay. That was in general. I wish to show you it in GeoGebra for a few seconds. So let's choose some random a. Let's choose some not so random function. Choose a function. What? What? No, that's silly. It's a straight line. I'll do x plus 1. I'll do it, but it was a silly answer. Wait, I'm doing it. No, just to shame you. So what is the tangent? The tangent is y equal f of a plus f prime of a times x minus a. Agreed? Where is the tangent? It's the extra line because you chose badly.
X squared.
X squared.
Yeah.
Ah, that is nice. And I can play the a, and now the tangent is rolling over the parabola, right? And I can choose whatever function, sine of x squared plus e to the x. And still, oh, that really is circus thing.
I think the problem is that you did nothing to the power of x.
Yeah, where's
No. It's not, there is no problem
Where's the stat?
other than I hope it will work if x is between -2 and 2. It needs to print. No, it didn't work at all. Yeah, I hate GeoGebra. Okay, if -2 x2, then sine of x, what was x squared plus e to the x? Yes. Okay, so yes, great. And now it will work. Yeah, now it works nicely. Because you had to print so many dots on the line, you computer guys, you should know it. The programmers behind it were horrible. And at each frame, I'm guessing, to be honest, but I'm pretty sure that's what they did. At each frame, they print everything, so it makes it collapse. Yeah. Okay, but you see my point, right? Okay, it works. So first of all, it's nice by definition. Okay, double. Fine. And now let's do it for x cubed. First of all, we need to calculate the derivative. That's from high school. And not x cubed, the cube root of x. That's x to the power of a third. Therefore, the derivative is a third times x to the power of -2/3, right? Which is 1/3 times the cube root of x squared. Agreed? So therefore, the tangent at x equals 8 is y minus f of 8, which is, all right, it's the cube root of 8. Something went wrong. Square root 3 to cube root of 8 equals 1/3. I'm going to copy it. That's right, 8 instead of x. And times x minus 8. Agreed? What is the cubed root of 8? So y equals 2 plus 2 squared 1/12 x minus 8. Agreed? Yeah? Okay, let's go for the GeoGebra. F of x equal x to the power of third. Yay. A equals 8. Yay. And does it not show the calculation? It's annoying because a minute ago it showed it. It showed it the same. No, it didn't show the calculation. So there's even something good about it. We'll write it ourselves. Y equals 2 plus 1/12 x minus 8. Not even close.
It's tough, not
I
close.
did one of it.
Ah, thanks. Oh, nice. Okay, so that's the actually tangent line. And what is most interesting about it, or something interesting, we said that the tangent line is supposed to be close to the function, meaning this cube root of x supposed to be close to 2 plus 1 over 12 times x minus 8. Agreed? Is it true from what you're seeing? Near to 8, yes. But as you go far along, not so much. Agreed? Yes. So what is the cube root? Now you are all promoted to calculators. Call me Casio.
Does this come with a raise in pay or?
I'm doubling your salary, okay?
Would you like
They're-
a document
they're
or
too.
something, right?
Yes.
An approved to buy.
Do we have to sign the?
So what would be the cubed root of 9? Just about. Not exactly.
Something.
2 plus something. That's exactly correct.
Look, we're not seeing it. You-
But you can read on the board.
2.112. Well, you know, 2 plus 1 plus 6.
That was horrible. 2.112. That's 2 point pi. That's yeah, okay. New kind of math. Proof that pi is a rational number. Pi over 1. Pi point 0.
If I remain irrational, I remain rational.
Yes. In any case, it's 2 plus 1 over 12. So that is not we missed the wow effect since you don't understand either number. But now but now let's go to Wolfram. And on the one hand, we'll write the cubed root of x, not x, of 9, which is according to Wolfram. No,
What do you encode?
no, that was 2 plus 2/3. It's 1/12. It's lower than 0.1. It's funny that it's not being able to.
Calculate.
Yes, I'm not
Better
sure.
than you.
Yes. No, you're not.
Can I calculate? No.
We were not able to
Yeah.
read the text on the.
Yeah, exactly. To be honest, he is not able to read text as well. But ChatGPT is better than both.
You can check.
At all.
You will see in a
It's not
second.
working.
You weren't supposed to.
I think
Yes.
it's not-
Are you also the same?
Yes, the status is not good.
You don't know.
Ah, what? Why is it?
Because he pays.
Ah, I pay too,
Why do you pay?
No, why did it work?
because I. You
So it's 2.8. Now do 2 plus 2 plus 1 over 12.
Depends more.
Yeah, I think so, because.
Look. Wow, look how much of a calculator are we? Okay. So we see 2 point, right? It
5
works.
minutes down to me, I hear.
Oh, your
Their server status is awful.
I see. Okay, in any case, we see 2.08 on both cases. We were able to calculate all by ourselves 2 digits after the decimal point. In general, you said it before, how can we better the approximation? So you said go to another point, but we need points where we can substitute into the cube root. So 8 is fairly carved in stone. The actual answer is the Taylor series, Taylor polynomials, which are higher level degree of that. Tangent that mustn't be aligned. Tangent, it mustn't. It's not mustn't. It doesn't have to be aligned. We can take the tangent parabola or tangent polynomial and get better approximation. A note about physics. Are you ready for this? A note about physics. Say I am at 100 kilometers at some road. Say I am driving at the speed of 80 kilometers per hour. Okay? Where do you guess I shall be half an hour from now? Physicist. Oh, physicist.
Yeah, you know.
I'm going in the positive direction and give me your best guess.
104.
140. Agreed?
Yeah.
And why is that? Can you tell me? Break it down to a calculation? You said 100 is the point I started from, plus the speed, which is 80. What speed in calculus?
9.
It was, yeah. That's exactly. Derivative, rate of change, that's speed. Times what?
30 over
The
60.
time that passed, which is a half an hour minus the 0 time we started with. This is exactly derivative. And you were rightfully so you were saying that if I change the speed, it won't be relevant anymore. If the movement is not altogether a straight line, it would, as we go along, it will go further and further. The derivative is true as long as the speed is relevant. But when the speed changes, then slowly the tangent line, which is the assumption that the speed is fixed, slowly changes. So instead of assuming all the speed is fixed, that's just for the physicist here, what can we assume is fixed? For instance, if I drop this wallet, the speed is not fixed. What is actually fixed?
Rate of change.
No, the rate of change is the speed.
The rate of change is speed.
Yes, what is the rate of change of speed? Acceleration, the second derivative. So Taylor is exactly that. If I assume that acceleration is fixed, I would get a parabola. And that's the tangent parabola to the graph of the function. And it's usually more accurate than the tangent line. And we can do it in every order. That's calculus too, to be honest. Then you'll learn about Taylor, but it's important for me for two reasons. First of all, not all lectures even say the stuff I said. That's one thing. And the second is you realize just how much derivative is important. Okay, so maybe you want to look at the second derivative or the third derivative. You know, by the way, what is the third derivative? If the first is velocity and the second is acceleration, do you know what the third is?
All days.
Jerk. It's actually called jerk. I'm not sure why, but it's true.
Acceleration divided by time.
Yeah, the derivative. Yes. Yes. Yeah, that's the jerk. Yeah. Yeah. No, just why it's called jerk. It's funny. That's all. It wasn't a mathematical or physical. It was just funny. It's called being jerked.
J.
Yeah, jerk.
Capital J.
What is a jerk? Let's look, Chapati.
Now you're paying.
Yeah.
I did not like that answer. What is a jerk? An annoying, stupid, or foolish person. Okay. I was wondering. N physics. The rate of change of acceleration, yeah. Yeah, I like the AI of Google. Reddit for them. Yeah, it's a reasonable source of information. Yes, great.
Then you have Snap and then Crackle.
Wow. Oh.
Why
Yeah,
are there even names in it?
that's what the academy does.
The sixth derivative is going to be pop.
Yeah. Okay.
Some people snap, you start using your eyes. I see that's what happened.
First you slap, then you crackle. It's a joke from Seinfeld. Where is
Not
that?
what he was trying to say, but doesn't matter. We're enough of a tangent already. Let's go.
Okay. So I've taught you all I have to teach, not in general. I have many more things to say, but like in what is the derivative? What does it measure philosophically, geometrically, physically, whatever. Now, next, we'll do another calculation without a story behind it. Look at the split function. When x is different than 0, it's x sinus 1 over x. And when x is 0, that's 0. Let's derive it. What is the derivative of this function at 0? So it would be the limit as x goes to 0 of f of x minus f of 0 over x minus 0. Agreed? Don't you see that's just a formula for the tangent line? It's good that now you're asking, but it was better if you did it before.
Oh, where X is time.
Right? Because that's the relative time. I'm saying the tangent line is the same thing as assuming the speed is fixed. And then I went on and saying that if we assume the acceleration is fixed, then you get Taylor polynomial of order 2. Okay. So agreed so far? That's the slope of the chord. the slope of the chord. Slope of chord. Agreed? And that's the limit as x goes to 0 of x sine of 1 over x minus 0 over x, which is the limit as x goes to 0 of sine of 1 over x. And what is that? Undefined. Defined. We saw sine of 1 over x. It jumps around between -1 and 1. And if you remember, that's exactly the chord behavior I mentioned before, because it's the exact function I've shown you from the start of the session today. The chord is indeed moving between slopes of -1 and 1. That is undifferentiable. Agreed? However, if I change the function for when x equals not equal 0, it would be x squared times sine of 1 over x. That's the other function. When x equals 0, it's 0. This will be differentiable because f prime of 0 is the limit as x goes to 0 of x squared sine of 1 over x minus 0 over x and minus 0, which equals the limit as x goes to 0 of x times sine of 1 over x, which is y
Because X and
0 and it's not enough.
X multiplied by something between 1 minus 1 and 1.
Bounded. That's the thing. If it was an exam and you will tell me because this is 0, you will get marked down. But what you need to say, it's 0 times bounded. Very important. 0 times bounded, which is 0. Agreed?
Yep.
Let's derive the sine function. We are there.
Fine.
He tried his best.
Yeah.
The derivative of sine of x is the limit as h goes to 0 of sine of x plus h minus sine of x over h. Just look for a quick example. Let's do sine of 3 plus 0.01 minus sine of 3 over 0.01. No, but I'm not mistaken, yes. Let's see how much it is. Why is Wolfram failing along with ChatGPT? That's
I think
really weird.
nowadays they both work from OpenAI, and the OpenAI must have had a fire in the server room or something.
Yeah, but why is Wolfram from OpenAI? That's
But they have computation.
yeah.
Wow. Yeah. How are they fixing ChatGPT without Chat?
For a general formula of the derivative.
Mhm. Just a second, sorry. It says it's minus 0.99. but its reasoning is stupid because it says it's not stupid, are you correct, but it's not good for me because I wanted to show you that it's about cosine of 3. And he said, because it's about cosine of 3, that's the value. I don't know, wait, no. No, he gave us 2 of them. No, it says, this is the approximated value. This is, wow, that's really, it by himself, he understood what my point was, right? He says, this is about the value, this is cosine of 3, it's about the same, the derivative is cosine. Okay, that's not proof, but yeah, it was interesting.
By AI.
It's for reference, yeah. Sammy, what did you wish to say?
When you have a general formula for a derivative, even like you know how we said the general formula for the derivative of like to find.
You mean sum of functions, maybe?
I'm saying like for x sine 1 over x,
Ah,
it can like not at x, sorry at x.
x to the power of a, x to the power of a, you mean?
No, I'm saying that specific function we just saw, x sine 1 over x.
Ah, okay.
We can't get the derivative at 0, but we can get the derivative everywhere else, right?
Yes.
So we can do the get the derivative by definition, just not for 0.
Yes.
So that would be the caveat.
Yeah. We need it sometimes, and that's what I said last time with the light waves. When it's not split, there is no problem. But when you have a patchwork function, then you have to use the definition. So that's that's a specific example of a patchwork function. And at 0, you cannot use the high school derivative. But when you can use it, you can use it. I'll never tell you, you must calculate the limit by definition, but sometimes that will be the only answer. Okay. And so for example, not example, let's derive the sine function, sorry. So does anyone have any guess as to the next step?
Yes, I have a guess. Okay.
What's your guess?
You're going to use trigonometric.
Yes, obviously, identities, yes. It's sine of x, cosine of h, plus sine of h, cosine of x, minus sine of x over h. Did that makes things better or worse? Better. Now let's order. Let's have some order in the classroom. Sine of x, I take it as a common factor. Do you see it appears twice? We are left with cosine of h minus 1 over h plus cosine of x, which is multiplied by what? Can anyone say anything smart?
Do we have to?
No, I asked if you can. You can say yes and then be quiet, leaving me to wonder.
Why? You put the sign X first. Okay.
Does anyone recognize anything?
So disappointed.
Maybe we can see that the h tends to 0,
Yes.
and we have a cosine of h minus 1 over h.
No.
No? Okay.
On the right hand part, on this.
Yeah.
I'm so great. I'm so happy that I spent a whole lecture just talking about that for you to answer this way. It goes to 1, right? Remember, we did learn it when there was X written inside. Yeah, sine of X over X. Yes. But when the argument inside goes to 0, we proved the theorem which we worked very hard on to prove that this goes to 1. Okay, I'll show you. And I also emphasize that why is that so important? Because it's used when deriving sine. And then we derived sine and used it, and you were all, what? Okay. That's that.
Okay.
Love without afraid. It's funny because before starting this semester,
Wait,
last
can you say
semester,
that for a bit so I can analyze it.
What?
Uh,
What do you wish to? Here. We use the fact that a sine of x, which uses the result of the theorem, yeah. So now we're at this stage. We're deriving sine of x, and we use that theorem. You want to remember the proof? Yeah.
No, I don't remember. No.
That never happened.
Yeah.
Thomas,
That's-
we never saw it. Never.
I will take it like a
Yes.
fact. Okay.
Yes, that's the second, yeah.
was
I
thinking-
don't remember it. So I'll take it as a fact, and I don't remember that fact as well.
Yeah.
Okay.
Before starting last semester, I studied the trigonometric identities, and from not using them, it's like
Yeah.
gone.
Mm. But that's not trigonometric identity. Okay, yes, any questions? Any confessions? Yes. Forgive me, Shaina. For I have sinned. It's sin x over x. That's good. Okay, for I have not sinned. Sorry. Yeah, yeah. That's enough for me for today. Okay.
you'll have videos though.
Yes, yes. Okay, yeah. Yeah. But still we didn't finish. What about this one? What about the cosine of h minus 1 over h? So we do a bit of wouldn't it be nice? We multiply and divide by the conjugate. So it's cosine squared of h minus 1 over h times cosine of h plus 1. Do you agree?
Oh, yeah.
Which is what? What is cosine squared of h minus 1? Minus sine squared because of Pythagoras over h times cosine of h plus 1. Agreed? Again, wouldn't it be nice? Because we have sine of h over h. Is that familiar for anyone?
I think it was 0.
The sad part here is I'm not sure if you're kidding or not. Times sine of h times, let's do it in one fraction, times minus sine of h over cosine of h plus 1, which tends to, as h tends to 0, to 1 times minus 0 over, what do we have in the denominator? No, 2. Cosine of 0 is 1. So altogether it's 1. And 0.
Yeah.
So this goes to 0. This goes to 0. This goes to 1. So altogether, what is the limit?
It's cosine of x.
The derivative of sine of x is 1. That's a new, okay. That's sine of x, that's fixed because we're deriving at a certain x, 3. So sine of x is sine of x. Times 0, it's 0. That's cosine of x times 1. Altogether, cosine of x. And that's the and that's the reason the derivative of, that's a proof, the derivative of sine of x is actually cosine of x. And we needed, twice we used the fact that sine of x over x is 1 when x approaches 0. Agreed so far? Sammy, are you happy?
That's a no.
Writing down
Yes.
for
I asked you if you were happy.
I think the only one taking them here is that.
I think it's enjoying himself. I don't know.
Yeah, I'm happy as well.
Oh yeah.
Even when you give right answer, I'm happy because I'm a good teacher. And when you give false answer, I'm happy because I have a comedy show. So I'm happy either way.
You say this now, but when we get the exams and you have to win the trenches for what will be probably like a day or something, because we're only like 8 people, you're not going to laugh that much.
Okay. I will. We were just having conversation the other day about the unnecessity of too many Moed Gimel, basically. And one of the lecturers said, yeah, once I did Moed Gimel, 8 people came, I failed all of them. And we're all like, ha ha ha.
Even
Yes, yes. I will prefer for you to succeed, to be honest. But I can view the beauty in other things as well.
But the script that in May was not like it was really what we're doing.
I don't know. I didn't need to go. You're
It
the
appeared
retard
from nothing. It just in our application. It's oh, we have more given after 2 months after more bed.
Probably, but someone was in Miluim.
No.
That's usually the reason. Usually the reason one person deserves a Moed Gimel, and then they open up and everyone sees it, and then started to fuss and say, "Oh, I want to join as well."
I didn't want. I just understood.
I don't want it.
Yeah.
Right, what I heard is
Can you cancel the Moed I did go to? Can you bring me back my?
what I heard is that if you do Mod Aleph and pass and do Mod Bet and fail, you can get to the Mod game.
No, but you don't. They would never write a special Moed for you. You are allowed to have the exam then the following semester, the following year. Moed Gimel is usually for Miluim, but it's enough one person in Miluim to write Moed Gimel. Okay. Another example which I like.
Cosine.
No, cosine is the same. Do it as HM. Okay, another example. Consider the function f of x equals the square root of x to the power of 4. Is f of x differentiable at x equals 0? And I wish for you to take a couple of minutes and try to solve it and actually answer me using high school tools.
Like ChatGPT or what?
No, not ChatGPT. I did have the conversation with ChatGPT. I think it was wrong once. I assume today he would be correct. I will check it myself, but try yourself to calculate it. No, what I wrote. I have no mistake here. Is that function differentiable at x equals 0 using only high school tools? You need to see there are two different answers that seem reasonable.
One is not.
And the answer is yes. You're a genius.
One is not. The answer is yes. So conclusion, it's too late. Not enough to late.
Is it true or not? I see the two solutions.
I see the two solutions.
Yes
Yes or
and
yes.
no.
Because I didn't study statistics, I would say it's a 50% chance it's yes, and 50% it's no.
Is this function differentiable at x equals 0?
Obviously.
Do you know the movie, The Platform? It's a Spanish horror movie. So there is a guy there who always say obvio, which is obviously in Spanish.
Yes, I can.
Yeah, so it reminds me of you.
I can confirm.
Did you watch the movie?
No, I speak Spanish.
Yeah, I know, I understand. No, I understood it.
Which
But you must watch it. It's on Netflix. My only criticism about the movie is that it's in Spanish, so it's hard to follow.
same.
But it's a very good one.
How is it called?
The Platform.
Oh, I've heard it.
Yeah, there is the Platform 2, which I didn't see it, but yesterday we saw the one again in order to be prepared. Yeah.
I'll say yeah, but you mean.
Obvio. Okay, so what are you saying? What is your answer? Is this differentiable or not?
Yes.
Everyone says yes. Sammy, what do you say?
Yeah.
Why do you say yes?
That's because
So answer one, f of x actually equals x squared. F prime of x is 2x. F prime of 0 is 0. Fine. Answer 2. F prime is 1 over the square root of 2 times the square root of x to the power of 4 times wait,
4, no, 2 x.
times 4x cubed.
Oh, yeah.
Agreed? That's the derivative. What is f prime at 0? Undefined.
But we can't make this up because it's.
What do you mean because it's 0? What's the problem with 0? How do we know ahead?
You can write it, but if you try to do it with this 0, it's undefined. That's all.
We're limiting the.
I'm still not understanding why is that not allowed? What's the mistake that I did?
You're dividing by something.
No, obviously that's the reason it's undefined, but think about it. Do you agree that that's the derivative?
We're using the chain. and
Yes.
We haven't defined the chain. Yeah.
So you say that math is true or not?
It's going to-
According to my class,
It's
that does not make sense.
That's how the test works now.
Yes, you didn't define
Might
it yet.
as well be the word
After we'll prove the chain rule, it will work.
No, it's just.
No, because maybe
we
the
have to
chain,
observe
maybe the chain rule only, like we haven't defined it in class, but too, maybe the chain rule only works in certain situations.
You're correct. You are correct.
So why are you gaslighting me?
Before the exam, I
That's
define
it.
the
Yeah.
Because you said well, you didn't define it yet.
I'm sorry, I wasn't
Yeah.
specific enough.
Yes.
You know
yes.
you knew what I meant.
No, I didn't. I honestly didn't. But you are correct, because then usually students don't say it. In order to use the chain rule, which we use here, we need to use 2 differentiable functions. Who are the 2 functions here? X to the power of 4 and square root of x, the root of our evil. It's not differentiable, it's 0. We are not allowed to use the chain rule here. Okay, he's so happy. Obvious, that's what I meant. Yes, no, I will never hit you.
I will.
Yeah, I'll ask Tomas to do it. Okay.
So I learned the chain rule. I never learned.
Yeah, because you don't learn things like this in high school. And now I will really blow your mind.
Never give you a question which.
Now I will really blow your minds. Get ready to be blown. F of x is the square root of sine of x to the power of 4. is this function differentiable at 0?
I think,
No.
yeah, yes, because x to the power 4 is always positive. And sign will be
No, but what's the
What
sign?
is the derivative? Is there a derivative, and if so, what it is? Yes,
It's a-
but is it defined?
No, because like because it's not defined for the square root. It also doesn't work here. That's the idea. Didn't you say?
Which one of these two answers were correct? Yes. So don't go back to that, look at the wrong answer and say, let's use the same argument. No, that's false. False. So you cannot use that argument. Using that's assuming by contradiction. Yes, let's use a false argument. Okay. Can you ask ChatGPT the following? What is f prime at 0 if f of x equals square root of sine of x to the 4? I wonder what will be the answer. The reason I'm not asking myself because he remembers our previous conversation and I corrected him about it, so he might just know. I wonder if without my help he knows the answer.
units. Final answer is 0.
Well, it's surprising. It does getting better and better.
And I understand. First example with the square root x to the power 4. If we write it like we can write x to the power 2 like this, but we can do it with undefined, but we can do it with 0. So we cannot do it 1.
This is false because we are not allowed to use the chain rule in this situation.
Okay.
Because the square root is not differentiable. This explanation is completely coherent and true.
That's
Yeah. But here, I was building up. Here you cannot cancel anything because the sign is stuck there, right? So what do we do here? Yeah, exactly. We must derive by definition. And that's what I'm saying, GPT. That's what I'm saying. I won't force you to derive by definition. Sometimes it's the only option. So f prime of 0 is not split. It's the limit as x goes to 0 of square root of sine of x to the 4 minus 0 over x minus 0, which equals the limit as x goes to 0 of the square root of x sine of x 4. And I'm doing a wouldn't it be nice? I want, what do I want? I want you to know it. Say it. What do I want beneath the sign here? No, that's. What do I want here to be written?
X to the 4.
X to the 4. Why, Thomas? Because what do you mean? This is not simplified, it's not an identity, but this goes to 1. I know this limit, right? So I multiply by x to the 4. Agreed? that equals the limit as x goes to 0 of the square root of sine of x to the 4 over x to the 4 times, where is the times x squared over x, which is
1 times 0 is
x times this. Wait a second. Right? Which is 0 times 1, which is 0. The derivative is actually 0. And I had to calculate it by the definition because the formulas did not work because I'm not allowed to use the chain rule. We will learn about the chain rule in the upcoming lessons, and I'll remind you of this. Any questions thus far?
It better.
It gets worse. Okay. Any limit, the wouldn't it be nice part is very heavy. You try to get to something you know, and then fix it. It's a general way of life in a sense, but in limits it's very, very common in mathematics all the time. Okay, next.
Take out a massive mortgage.
What?
Want a nice house? Buy a nice house and take out a massive mortgage.
Yeah, that wouldn't be nice. Yeah. Yes. Yeah, in a sense, that's true. Many people do it, but you're not in with times. It used to be if you want to buy a nice house, you buy a nice house and get a mortgage. Today, if you buy a house, if you want a house, you buy a house. The nice part is you can't allow yourself even a regular house, a crappy house, right? Not talk about a nice house. Okay. An important limit. You will see later where would I use it. What is the limit as x approaches 0 of log, doesn't matter in what base, of 1 plus x over x? To 2 to 2, that's obvious the answer. The numerator, where does the numerator tends to? Just a second. Yes. Yes, just a second. I'm writing something for next lesson that I won't forget. What is lecture 19? I always forget it, but I remember it now. Lecture 19. And differentiable is continuous. That's for next lecture. In any case here, they both go to 0. So what can we do? Yeah, great. That's the bad answer, obviously. So does anyone have a nice idea as to what to do? Thomas, maybe you have an idea.
Take the log of something else.
Yeah.
Take the log off. No.
What is?
Okay. You are not allowed to split the log. Log of prod. What did you suggest? No, but it was in the direction. Okay. It's 1 over x times log.
Okay. So now you put that to the power of 1 over x.
Yes.
Yeah.
It's uber cool.
I have come up with a very nice definition. Finding the limit yourself.
Yeah.
Your sanity.
Finding your limit.
Fighting life is unbounded from below. People thinking, how horrible could hell possibly be? And now I understand. Yes. Okay. So, what is that? Boys and girls, what is that? Where does this tend to? E. Who would believe it? That's log. You still don't believe it because you never seen it, right? That's log A of E. And by the way, in high school, in Israel high school at least, they don't like log in any base other than E. So what do? They change the base. They say it's ln of E over ln of A, which is 1 over ln of A. And that it has to do with the derivative, but they use ln of A, and I hate it because when you actually do it in the right way, the straightforward way, you see the number E, which is important. Here, the number E does not appear directly, but in the actual derivative, you still don't know why is that a derivative. That will take me 2 more seconds, but that limit is actually a derivative. And in the derivative of some random log, the number E appears. And now we derive the logarithm function. Yay. With the change of the base. You choose whatever base you like, and you take the log of the number over the log of the old base. That's a formula. Okay. So what is the derivative of log base A of x? That would be the limit as h tends to 0 of log, not capital A, lowercase a, x plus age minus log A of x over age. Agreed? Now we can use logarithm rules and say that the numerator, the one on top, this is a running joke from linear, right? It wasn't linear. Is the subtraction of logs is the log of the quotient. So it's log of x plus age over x over age, agreed? Which is the limit as age goes to 0 of log A of 1 plus age over x, which goes to 0, right? Because age goes to 0. Wouldn't it be nice? What would I like to be exactly beneath it in order to use this rule? If I have log of something of 1 plus 0, I want to divide by the exact same something, right? So I'll write it age over x. But it's not what's written. So how can I fix that? By 1 over x. Agreed? Where does this goes to? Log A of E, log A of E. So the derivative is actually log A of E over x. And in high school, it is better known as 1 over x ln of A. And it's the same. And specifically, if A is E, we get the derivative of ln x, which is the derivative of log base E of x, is log in base E of E over x, which is 1 over x. Okay, so we have the derivative of log as well. For next time, we will derive also and derive and derive exponent. Then we shall persevere. Have a nice week.
Yeah.
No problem. I can even open it. Calc one.